Prove that for all positive values of x and y, the square root of x, y, is less than or equal to x plus y over 2. So this is the result that I'm trying to prove. And I don't know what my starting place is in this question. So this is one of those reverse engineering questions where I'm going to do some rough working out with the answer until I can figure out a suitable starting place. So if I'm starting with root xy is less than or equal to x plus y over 2. First thing I might think to do is to square both sides. Now I should be careful when I do this because this is an inequality and I might need to flip the sign when I square both sides. But the fact that x and y are both positive means that I know this here is positive. And so when I'm squaring both sides, I know I'm multiplying by a positive number. So that's good to know. So that means I don't need to worry about flipping the direction. Next, let's get rid of that fraction. Let's times both sides by 4. And whilst I'm at it, I'm also going to expand these brackets. So I've just times by the 4 there, and then expanded those brackets to get this. Next thing I'm going to do, I'm going to subtract 4xy from both sides so that my quadratic is greater than 0 or equal to 0. The 2xy minus the 4xy is minus 2xy. And now I notice that I can factorise my right-hand side to be x minus y all squared. Because I've got the x squared, I've got the x times minus y, which is minus xy, but then there's 2 of those, so minus 2xy. And then I've got the minus y squared. So that's been factorised nicely, and now I've got this square number being greater than or equal to 0, which I know is always true. A square number is always greater than or equal to 0. So that's my starting point for my final answer. I know that x minus y all squared is greater than or equal to 0. So if I expand the brackets, I'm then going to add 4xy to both sides. I'm then going to factorise on the left-hand side. I'm then going to divide both sides by 4. And then I'm going to square root both sides. And I know I'm allowed to square root both sides because x and y are positive numbers. And so what I've effectively done is I know this bit here is positive, so by square rooting, I have divided both sides by a positive number. So I know I don't need to worry about flipping the signs here. I'm going to cross my rough working out because I know I've got my final answer now. And then part B, prove by counterexample that this is not true where x and y are both negative. So let's pick a value of x and y where they're both negative. So I'm going to say that x is, I'm going to go minus 2, and I'm going to say that y is minus 8. The reason I selected 2 and 8 is because I know they're going to multiply together to give me a square number that's going to square root nicely. So that will give me the square root of 16, which is 4. And when I add them together and divide by 2, I get minus 10 over 2, which is minus 5. And clearly 4 is greater than 5. So therefore, not true. When x and y are negative. Because if x and y are negative, then x plus y over 2 would be negative. And when I square rooted both sides, that would be me dividing both sides by a negative, and so I would have had to have flipped the sign in that case.